As promised, activity 8.2, part 2. Event A is the card is a face card. Event B is the card is a spade. Does the equation hold? Okay, so first of all, let's set up our equation here. We know it's the probability of A and B. Does that equal the probability of A? Actually, let's mix it up this time. Let me go back. Let me go B given A this time. B given A times the probability of A happening by itself. Okay, so here we go. First things first, we've got to find the probability of A and B. A and B. So A and B. Event A is the card is a face card, and it's a spade. So our face cards are obviously the cards that have a face, and it's also got to be a spade. So how many spade face cards do we have? Well, if we go to our spades, I can see I have the Jack of Spades, the Queen of Spades, and the King of Spades. Those are 3 cards with a face, and that's out of my total of 52. Check. Okay, next one. What is the probability of B given A? Always start with the denominator. We always start here. And event A is that the card is a face card. So how many total face cards do we have? Well, you can see down here in green, I'm highlighting, I've got 12 total face cards. Out of those, how many of them are spades? Well, we already said there's 3, so that's 3 out of 12. And then the last thing we do, let me switch up my colors here. The last thing we do is we find the probability of event A happening by itself. Well, event A is that the card is a face card. So out of a standard deck of cards, there's 52 of them. How many of them are face cards? Well, there's 12. I already have those highlighted in green. So now I take this equation and I set it up. So now I'm taking this and I'm going to move it down to here. So here we go. The probability of A and B, we already said that's 3 out of 52. Does that equal the probability of B given A? So that's going to go here. That's 3 over 12. We just found that. Times the probability of A happening by itself. Well, that's 12 over 52. And take a look at what happens. The 12s cross cancel again, and everything once again checks out. We are proving Kieran's equation, Kieran's thought process, that these do in fact check out every single time, proving our multiplication rule.